You open your eyes. Everything is still. Not the stillness of a room, not the stillness of a quiet night, the stillness of a place that has always been still. A place where nothing moves quickly. A place where the cold is so complete that even the molecules in the ground beneath you have slowed to almost nothing. You are lying on Pluto. The ground under your back is nitrogen ice, frozen nitrogen, packed into smooth plains that stretch away from you in every direction, pale and flat and faintly pink in a color that has no good comparison on Earth. Not white, not gray, a specific reddish tan at the horizon where the rock and ice mix together. And here in the basin where you have woken up, a pale nitrogen white that is almost luminous in the dim light. You look up, the sky is black, and in the sky, you look for the sun. You find it, and it is a star, not a disk, not even close to a disk. A star, the brightest star in the sky by a very large margin, but a star, a point of light, cold and distant and sharp in the black sky. That is the sun. From here, the sun is just a very bright star, and Pluto is just a very small world, a very small, very cold, very quiet world that nobody calls a planet anymore. In 2006, the International Astronomical Union voted. The vote was about Pluto, about what Pluto was. Pluto had been discovered in 1930 and called a planet for 76 years. Then a definition was established. A planet, the Union decided, must orbit the sun, must have enough mass to pull itself into a roughly spherical shape, and must have cleared the area around its orbit of other debris. Pluto meets the first two requirements. It does not meet the third. Its orbit is shared with hundreds of other Kuiper Belt objects. It has not cleared its neighborhood. So Pluto was reclassified. Dwarf planet. People had feelings about this. Strong feelings, surprisingly strong feelings, about the status of a small frozen world, 5.5 billion kilometers away, that none of them had ever been to, and most of them had never thought about before the vote. Something about the demotion felt wrong to people. Something about taking away the name, the category, the planetary standing that Pluto had held since 1930. Children had learned the planets. Pluto was one of them. And then it was not. Pluto did not notice. Pluto continued its orbit. It continued its 248-year journey around the sun, the same journey it has been making for 4.5 billion years. It continued freezing in the long winter of its elliptical orbit and thawing slightly in the brief summer when it swings a little closer to the sun. It continued holding Charon in its gravitational embrace and spinning slowly and carrying the heart on its surface. The heart. When the New Horizons spacecraft flew past Pluto in 2015, its cameras revealed a feature no one expected. A vast pale plain on Pluto's surface in the shape of a heart. Smooth nitrogen ice, 2,000 kilometers across, shaped by forces that scientists are still working to understand fully. A heart on the most demoted, most forgotten, most distant object in this series. You are lying in the left lobe of that heart right now. In this story, you are on Pluto, the last stop, the end of the series, the small world that lost its name and kept its heart. The nitrogen ice beneath you is smooth. Not ice the way you think of ice. Not a skating rink, not a frozen lake. Nitrogen ice at these temperatures is not slippery. It is hard and still and dense. The molecules locked into place by a cold that is 230 degrees below zero. The surface of the Tombaugh Regio, the heart-shaped plane, is one of the smoothest large surfaces in the solar system. No craters. At the craters that should have accumulated over billions of years of meteorite impacts have been erased. The nitrogen ice flows very slowly over geological timescales, filling in the craters as they form. The heart heals itself, very slowly, but it heals. You put your hand flat on the surface. The cold arrives through your palm immediately, not a gradual cooling. Contact with nitrogen ice at -230 degrees is not a gradual process. The cold is there at the first moment of contact, and it does not negotiate. It simply begins its work. Your skin registers the temperature for a second, and then the nerves responsible for registering temperature at that depth cease to function at that temperature. You lift your hand. You look at it. It looks unchanged. The cold has not changed what your hand looks like, yet it has changed what is happening inside it. You look around. The plane is vast. It extends beyond sight in every direction from where you are lying. At the edges, very far away, mountains rise. Not hills, mountains. Ice mountains made of water ice rather than nitrogen ice, because water ice at these temperatures is as hard as rock. The mountains of Pluto are made of water that has been cold for 4.5 billion years and has become, in that time, as strong as granite. They rise several kilometers above the plain. Their peaks catch the faint starlight between you and the mountains. The heart, 2,000 kilometers of smooth, pale ice, shaped somehow into the outline of a heart. Left lobe and right lobe. You are in the left lobe, the one made entirely of nitrogen ice. The right lobe is slightly different terrain. But from where you are, the plane stretches away in every direction, and the word heart makes sense, even if the reason for the shape does not yet make sense. Pluto's surface is red-brown at the edges. The color comes from tholins, complex organic molecules created when ultraviolet light from the distant sun reacts with the nitrogen and methane in Pluto's thin atmosphere. Tholins are reddish. They coat the areas of Pluto's surface that are not covered by fresh nitrogen ice. The heart is pale because the nitrogen ice is fresh, relatively speaking, constantly renewed by the slow geological cycle of the plane. The rust red surrounds the pale heart. The heart sits in the middle of the rust. You sit up and find the sun again. You found it from the atmosphere of Neptune. Here it is the same bright point, but different in character. On Neptune you were inside an atmosphere. The atmosphere gave context. The atmosphere was doing things. The sun was a feature of a busy sky. Here there is almost no atmosphere. Pluto has one. Very thin. Nitrogen and methane and carbon monoxide, existing as a thin shell around the planet during the part of its orbit, when it is close enough to the sun for surface ices to sublimate. But it is so thin that the sky through it is black. The stars are sharp. The sun is sharp. There is no scattering of light, no blue sky, no diffusion. What you see is what is there, without any atmospheric filter. And what is there is a star. You know it is the sun because you know which direction to look. Because it is brighter than the others. Because the light from it, when you turn your face toward it, carries warmth. Not much warmth. Almost no warmth. The sun from here delivers about 1,000th of the energy it delivers to Earth. On Earth you can feel the sun on your skin on a winter day. Here, you could not feel it even with instruments designed to measure very small amounts of heat. But it is there. The source of everything in the solar system. The thing that 8 planets orbit, that hundreds of moons orbit, that millions of smaller objects orbit. The thing that was overwhelming on Mercury, that drove Venus into its runaway heat, that gives Mars its brief warmth in summer, that Jupiter and Saturn and Uranus and Neptune all exist in the light of. From here, it is a point of light. From here, it looks like any other star. From here. Thus, if you did not know, you could not find it. The light from the sun takes 5.5 hours to reach Pluto. 5 hours and 31 minutes, traveling at 300,000 kilometers per second, across the distance between the sun and this small frozen world. When you look at the sun from here, you are seeing it as it was 5.5 hours ago. 5.5 hours ago on Earth, people were doing ordinary things, drinking coffee, commuting, working, whatever ordinary things were happening 5.5 hours ago on a planet you cannot see from here. The light from those moments is still traveling outward. It will pass Pluto soon. Then it will continue into the Kuiper belt, then into interstellar space, The light keeps going long after Pluto, long after everything. Charon is above the horizon, not high above, low. Charon and Pluto are tidally locked to each other, which means Charon always shows the same face to Pluto, and Pluto always shows the same face to Charon. They orbit their common center of gravity together, turning together, always facing each other. If you are on the side of Pluto that faces Charon, Charon is always there. It never rises or sets. It sits at the same point in the sky, day after day, year after year, the same face of the same moon at the same position in the sky for as long as you are on this hemisphere. You are on this hemisphere. Charon is there. It is large. Not as large as the moon looks from Earth, but large for a moon relative to its planet. Charon is about half the size of Pluto. Most moons are tiny compared to their planets. Charon is not tiny. Pluto and Charon are almost a double object. Two bodies orbiting each other. Some scientists call them a binary system, rather than a planet and its moon. Charon's surface is gray rock and gray ice, heavily cratered, ancient, with a large dark region near its north pole that scientists call Mordor. The dark material is thought to be the same tholins that color Pluto's surface, captured from Pluto's thin atmosphere and frozen onto Charon's pole over billions of years. Pluto has been slowly painting its moon with its own material for 4.5 billion years. The paint is dark. You look at Charon. Charon looks back. Or rather, Charon faces you. The same face it has always shown this hemisphere of Pluto. The same ancient cratered surface. The dark North Pole. The gray and rust of a moon that has been in this position, in this relationship. Since something enormous struck Pluto long ago, and the impact threw out the material that became Charon. They have been facing each other ever since, through 4.5 billion years, through everything. Pluto and Charon were formed by a collision. Early in the solar system, something large struck Pluto. The impact threw debris into orbit around Pluto. The debris coalesced into Charon. The same process that formed Earth's moon. The same violent beginning, the same result. A world and its companion, locked together, always facing each other across a small gap of cold space, turning together through the outer solar system. Pluto and Charon have been looking at each other since before multicellular life existed on Earth. They will be looking at each other long after the last trace of that life is gone. Minus 230 degrees Celsius. This is the coldest surface temperature in this series. Colder than the rings of Saturn, colder than Uranus and Neptune, the coldest place you have been. The specific cold of a world so far from the sun that the sun's warmth is essentially zero, and the only warmth is the faint residual heat of the world itself, slowly bleeding away into space. The cold here is very quiet. This is the thing that distinguishes Pluto's cold from the cold of the gas giants. On Neptune, the cold came at you with the wind. 2,100 kilometers per hour of cold atmosphere, delivering cold at speed. On Saturn, the cold was in the ice all around you. On Uranus, the cold was dark and pressing. On Pluto, the cold simply sits. And it sits in the ground and in the thin air and in the light from the stars and in the ice mountains at the edge of the plain. It sits with the patience of something that has been this cold for billions of years and is not in any hurry. It is not doing anything to you specifically. It is simply the temperature of the place. The place has always been this temperature. The place will always be this temperature. You have arrived at the temperature, and the temperature does not adjust. You feel it in the ground through your back. The nitrogen ice conducting cold, upward through your clothing, with the steady efficiency of a material that is much colder than you are. The ground is not trying to cool you, and it is simply colder than you, and heat moves from warmer to colder, and you are the warmer thing, and the ground is the colder thing, and the physics does the rest. your back, then through your back. Then the cold is inside you, past the skin, in the tissue, moving toward the places that need to stay warm to keep you here. It moves slowly. Everything on Pluto moves slowly. At minus 230 degrees, nitrogen is solid. The nitrogen that makes up most of Earth's atmosphere. The nitrogen that you breathe out with every exhalation. The nitrogen that is the most common gas in the air surrounding you on Earth right now. Here it is frozen into the ground. The ground you are lying on is made of something that is a gas on the planet you came from. You are lying on frozen air. The solar system contains this fact without apology. Pluto has an atmosphere. This surprised scientists. A world this small, this cold, this far from the sun, retaining any atmosphere at all, was not guaranteed. But Pluto does. Nitrogen and methane and carbon monoxide, existing as a shell so thin that the atmospheric pressure at the surface is about 100,000 times less than the atmospheric pressure at Earth's surface. You cannot breathe it. Not because it is toxic, though it would be, but because there is essentially nothing there. Breathing the atmosphere of Pluto would be like trying to breathe in a near-perfect vacuum. Your lungs would find almost nothing to process. Each breath would return almost nothing to your blood. But the atmosphere is real. It does things. When Pluto is at the closest point of its orbit to the Sun, the Sun's warmth is just enough to sublimate some of the surface nitrogen, turning it from ice directly to gas. The gas rises. It forms the atmosphere. The atmosphere creates a faint haze that the New Horizons spacecraft photographed in 2015. Layers of haze backlit by the sun, extending hundreds of kilometers above the surface. When Pluto moves away from the sun in its long elliptical orbit, the atmosphere freezes back out. The nitrogen gas falls back to the surface as snow. The atmosphere collapses. The haze disappears. Pluto's entire atmosphere freezes solid every time it moves far enough from the sun. The atmosphere breathes with the orbit. 248 years of orbit. A long, slow breath in when Pluto approaches the sun. A long, slow breath out when it recedes. You are in the thin part of the breath. Above you, if you could see it. The haze layers catch the faint sunlight. Very faint, very thin, but there. New Horizons took 9.5 years to reach Pluto. It launched in January 2006, the same year Pluto was demoted from planet status. It traveled 3 billion miles. When it arrived in July 2015, it had 16 minutes to take close-up photographs before it was past and gone, its trajectory carrying it onward through the Kuiper Belt. 16 minutes of close approach after 9.5 years of travel. In those 16 minutes, it photographed the heart, the mountains, the haze layers, Charon, the 4 small outer moons. The images took 16 months to download because the spacecraft was so far away. The data transfer was very slow. The closest look humanity has ever had at Pluto. 16 minutes, 9 years in the making, 16 months to receive. You lie in the heart and you think about why it is there. The honest answer is that scientists are still working on this. The Tombaugh Regio, the heart-shaped plane, is one of the most discussed features in the outer solar system. Precisely because its existence is not simple to explain. Why is this region smooth when the rest of Pluto is cratered? Why does the ice flow in a way that maintains the shape over billions of years? Why does the plane sit in a basin lower than the surrounding terrain? The leading theory involves a large impact. Something struck Pluto long ago. The impact created the basin. The basin being lower than the surrounding terrain became a cold trap, the lowest and coldest point on the planet, where nitrogen ice would naturally accumulate over time. The nitrogen flows into the basin from all directions, very slowly, filling it, smoothing it, erasing the craters as they form. The flow of nitrogen ice is driven by convection. the same process that drives ocean currents on Earth. Warmer ice rising and cooler ice sinking in a slow, steady circulation. The shape is an accident of geography. The impact happened where it happened. The basin formed the shape it formed. The ice filled it. The outline of the filled basin happens to resemble a heart when seen from above. Not because Pluto intended a heart. Not because the solar system is sending a message. Because a basin formed this shape and ice filled it. And from space, the ice-filled basin looks like a heart. The universe produces heart shapes without meaning to. The same way it produces hexagons at Saturn's pole and rings around planets and the specific blue of Neptune. The geometry is in the physics, not in any plan. But you are lying in it, in the accidental heart of the last world in this series. And the accidentalness of it does not make it feel less like a heart. The left lobe of the heart, where you are, is called Sputnik Planitia, named after the first artificial satellite, the one that started the space age. In 1957, the Soviet Union launched Sputnik, and the world looked up at the sky and saw the first human-made object orbiting Earth. 58 years later, New Horizons flew past Pluto and photographed a plane the size of Texas and named it after the satellite that started everything. The space age began with a small beeping object in low Earth orbit, and 58 years later, found a heart on the last world. This is the arc, Sputnik to Sputnik Planitia. Pluto was a planet for 76 years. From 1930, when Clyde Tombaugh found it in photographs taken at the Lowell Observatory, to 2006, when the International Astronomical Union changed the definition. 76 years of being a planet. Generations of children who learned the solar system with Pluto as the 9th entry. Textbooks with Pluto. Mnemonics with Pluto. A cultural presence that no other Kuiper Belt object has, simply because Pluto got there first, got named first, got taught first. Then the vote, and the name changed. Dwarf planet. People were upset. Some scientists were upset. The vote was close, and the definition was controversial, and the debate continues in some corners of planetary science. Mike Brown, the astronomer whose discovery of large Kuiper Belt objects essentially forced the reclassification, wrote a book called How I Killed Pluto and Why It Had It Coming. Clyde Tombaugh's family, his daughter and son, were still alive in 2006 and had opinions about the demotion of the object their father had discovered. Pluto did not have opinions. Pluto continued its orbit. This is the thing about Pluto that feels important right now, lying in the heart on its surface. The demotion changed nothing about Pluto. Not its size, not its orbit, not its composition, not its moons, not the heart on its surface. The vote in Prague in 2006 did not change what Pluto is. It changed what Pluto is called. The thing itself remained. Pluto is what it has always been. A small, cold, distant world of ice and rock, with a large moon that faces it always, with a thin atmosphere that breathes with its orbit, and with a heart made of nitrogen that heals itself slowly. The name is a human invention. The world is not. Clyde Tombaugh, who discovered Pluto in 1930, died in 1997, 9 years before the demotion. He was not alive to see his planet reclassified. He was, however, aboard New Horizons. His ashes, a small container of them, were placed on the spacecraft before it launched. When New Horizons flew past Pluto in 2015, Tombaugh's ashes were aboard. The man who found Pluto flew past it, in a sense. The first human remains to reach the outer solar system. The first human remains to pass through the Kuiper Belt. Tombaugh's ashes are now billions of kilometers from Earth, on a spacecraft that will never return, heading out of the solar system. He is still going. The stars are extraordinary from here. Every planet in this series had stars. Mercury had them in the daytime sky. Mars had them at night. Saturn's rings had them between the ice pieces. Neptune had them around the bright point of the sun. But here on Pluto, with almost no atmosphere to scatter or diffuse or soften anything, the stars are simply what stars are when nothing stands between them and you. Thousands of them. The Milky Way is a river of light across the sky. Not the pale suggestion of the Milky Way you can see from a dark place on Earth, faint and beautiful and slightly unreal. This Milky Way is dense and structured and vivid, the individual stars in it countless. The dark lanes between the star-dense regions clearly visible. The whole galaxy visible as a thing that has shape and dimension. You are looking at the galaxy. From here, from the edge of the solar system, the galaxy is the whole sky, and the sun is part of it. The small star that runs the solar system is one of the several 100 billion stars in the galaxy you are looking at. It is not distinctive. It does not stand out except in brightness, and its brightness from here is the brightness of being close, not of being special. In a few hundred light years, it would look like any other star. The universe is very large. You are very small. Pluto is very small. All of this was always true. It is simply more visible from here, from the last world, from the edge. The nearest star to the sun is Proxima Centauri, about 4.2 light years away. Light from Proxima Centauri takes 4.2 years to reach the solar system. From Pluto, Proxima Centauri looks the same as it looks from mirror Earth. A faint red point not visible to the naked eye, but there. 4 years of light travel away. And if you launched a spacecraft from here at the fastest speed any human-made object has ever traveled, it would take about 70,000 years to reach Proxima Centauri, the nearest star. 70,000 years. The solar system is enormous, and the space between solar systems is incomparably more enormous. You are at the edge of your solar system, looking at the nearest other one, and the nearest other one is impossibly far. There is no sound on Pluto. Not the no sound of Mercury's vacuum, not the compressed silence of Neptune's howling atmosphere, where the wind moves too fast for you to distinguish it as sound. The specific no sound of a world with a trace atmosphere and no weather and no geological activity visible at the surface and no life. A world that is simply very still. The nitrogen ice does not make sounds as it flows. The flows are too slow. The ice in Sputnik Planitia, the heart you are lying in, circulates on timescales of hundreds of thousands of years. The movement is real. The ice is moving. But it is moving at the pace of continents on Earth, slower than any process you could perceive. Your entire life could pass and the nitrogen ice around you would not have moved a measurable distance. The flow is real and invisible and silent. The mountains at the edge of the plain were built by geological processes that stopped long ago. Pluto is not volcanically active in any way that has been confirmed. The mountains of water ice were shaped by whatever forces acted on them early in Pluto's history, and they have been standing since then, slowly being covered by the thin fall of nitrogen snow in winter, slowly being uncovered when the nitrogen sublimes in summer. The mountains do not move. The mountains have not moved in billions of years. They are standing where they were placed. Everything on Pluto is very still. Everything on Pluto has been very still for a very long time. The cold keeps things still. At these temperatures, the energy that drives motion, geological motion, atmospheric motion, any motion, is almost entirely absent. The world has been cold for so long that the stillness is complete. You lie in the stillness. You are the only moving thing on Pluto right now. Your chest rising and falling, more slowly than before. But still moving. There is a possibility that Pluto has a subsurface ocean, liquid water, kept liquid by residual heat from radioactive decay in the rocky core, buried beneath the ice. Scientists have found evidence in Pluto's geology that suggests something liquid, may have been present at some point below the surface, and possibly still is. An ocean on Pluto, hidden beneath the nitrogen ice of the heart, beneath the water ice mountains, in the dark interior of a world at the edge of the solar system. There may be liquid water that has been there for billions of years. No one has confirmed this. No one has gone to look. And the possibility sits there, unconfirmed, in the interior of the last world. Pluto takes 248 years to orbit the Sun. One Pluto year is 248 Earth years. When Pluto was discovered in 1930, it had not yet completed a single orbit since its discovery. It completed its first full orbit since discovery in 2178. The people who will be alive when Pluto completes that orbit have not been born yet. The scientists who studied the New Horizons data are long dead by the time Pluto has gone once around the Sun, since they looked at it closely. The orbit is elliptical, very elliptical, compared to the near-circular orbits of the 8 planets. Pluto swings from 4.4 billion kilometers from the Sun at its closest to 7.4 billion at its furthest. When it is close, the atmosphere thickens. The surface warms slightly. Some of the nitrogen ice sublimes. The heart is slightly less frozen. When it is far, the atmosphere collapses. The nitrogen falls as snow. The temperature drops further than it is right now. Right now, Pluto is between the two extremes, moving outward on its long ellipse, moving away from the Sun, moving into the long winter. The winter will last decades. The atmosphere will thin further. The nitrogen will fall. The heart will be covered in a thin layer of fresh snow, and the snow will be very white and very still, and the sun in the sky will be a little dimmer and a little more distant, and the cold will be a little more complete. Pluto will continue, as it has always continued. 248 years per orbit, 4.5 billion years of orbiting, more orbits than any other number that is meaningful to say. The New Horizons spacecraft, after flying past Pluto in 2015, but continued into the Kuiper Belt. In 2019, it flew past a Kuiper Belt object called Arakoth, a small double-lobed contact binary object that looks like a red snowman, the most distant object ever explored by a spacecraft. Then New Horizons continued outward. It is still going. It will cross into interstellar space in about 20 years. It carries a message, as Voyager did, a digital message encoded on a chip containing images and sounds from Earth. The last spacecraft to visit Pluto is now heading for the stars, carrying a record of the planet it left behind. The planet that is no longer a planet, still carrying its heart. You have been to 8 worlds. Mercury burned you from both sides at once. Venus pressed you with 90 atmospheres and cooked you in acid air. Mars gave you hope and then took it back with the night. Jupiter swallowed you through its layers and its storms and made you part of its interior. Saturn gave you the most beautiful place in the solar system, and then slowly drew you down into the amber beneath the rings. Uranus confused you in the dark of its 42-year night. Neptune threw you through its blue with winds faster than sound. And Pluto is lying still. That is the difference. Pluto is not doing anything to you in the way the others did things to you. Pluto is simply here, and you are on it. And the cold is working on you, the way the cold works on everything that arrives on Pluto, without the ability to generate its own heat indefinitely. Slowly, thoroughly, without urgency. The heart is beneath you. 2,000 kilometers of smooth nitrogen ice, shaped by an impact billions of years ago, maintained by the slow circulation of ice that moves too slowly to see or hear. You are a small, warm thing in the center of a very large, cold shape. The sun is in the sky, a bright star, the brightest star, the star that 8 planets orbit, that hundreds of moons orbit, that this small, demoted world orbits on its long elliptical path. The star that was overwhelming on the first world in this series and is a point of light on the last. The same star, just further. Charon is above the horizon, always above the horizon, always facing this hemisphere. The gray moon with the dark North Pole in its locked orbit, turning with Pluto, always facing Pluto, as it has for 4.5 billion years. The stars are everywhere. The galaxy is overhead. The silence is complete. The cold is very complete. The breathing is very slow, slower than before. But still, you are on Pluto, the last world, the small world with the big heart, the world that lost its name and kept everything else. You are in the heart, and the heart is holding still, as it has always held still, as it will hold still long after you are part of the cold. Close your eyes. The ice is very still. The sun is a star. The heart is very large. You are in it. A note of science. Pluto was discovered on February 18, 1930, by Clyde Tombaugh at the Lowell Observatory in Flagstaff, Arizona. He found it by comparing photographic plates of the same area of sky taken several days apart and noticing a point of light that had moved. He was 24 years old. In August 2006, the International Astronomical Union adopted a formal definition of a planet, requiring that a body must orbit the Sun, have sufficient mass to assume a rounded shape, and have cleared the neighborhood around its orbit. Pluto meets the first two criteria, but not the third. It was reclassified as a dwarf planet. The vote was 424 in favor and 333 against, with 77 abstentions, out of approximately 10,000 IAU members, most of whom were not present at the meeting. The definition and the vote remain controversial among planetary scientists, and the Tombaugh Regio, the heart-shaped feature on Pluto's surface, was discovered by the New Horizons spacecraft in July 2015. The left lobe of the heart is officially named Sputnik Planitia. It is approximately 1,000 kilometers wide and is one of the smoothest large surfaces in the solar system. The smoothness results from a convective cycle of nitrogen ice that continuously repaves the surface. Models suggest the ice is about 10 kilometers deep. The reason the plane is heart-shaped is related to the geometry of the impact basin that created it. Charon is unusual among moons in that it is large relative to the planet it orbits. Charon's diameter is about 51% of Pluto's diameter. Pluto and Charon are tidally locked to each other, meaning the same sides always face each other. At the center of mass of the Pluto-Charon system is outside Pluto itself, causing them to orbit each other, rather than Charon simply orbiting Pluto. Some scientists classify them as a binary dwarf planet system. The New Horizons spacecraft launched in January 2006, the same month that a paper proposing a new planetary definition was submitted that would ultimately lead to Pluto's reclassification. It reached Pluto in July 2015, after a journey of 9.5 years. Its closest approach lasted minutes. The mission returned data about Pluto's geology, atmosphere, moons, and surface composition. The full data download, limited by the vast distance and the spacecraft's low transmission power, took about 16 months. New Horizons carried a small container of Clyde Tombaugh's ashes, placed aboard at the request of his family. Tombaugh died in 1997. He was 90. When New Horizons flew past Pluto, Tombaugh's ashes were the first human remains to reach the outer solar system. The spacecraft has since flown past Arakoth in the Kuiper Belt and is heading into interstellar space. There is scientific evidence suggesting Pluto may have a subsurface liquid water ocean, maintained by heat from radioactive decay in its rocky core. The evidence includes features of Pluto's geology that suggest past or present liquid water activity at depth. This has not been confirmed and would require a dedicated orbiter mission to verify. No such mission is currently approved. The solar system series. Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. You were on all of them.